The Theory of Political Economy by William Stanley Jevons. Chapter 7 Theory of Capital. Part 12 Dimensions of Interest. The formula which we obtained in the preceding section has been subjected to close criticism by an eminent mathematician who proposed several alternative formulae, but finally accepted my solution of the question as correct. As Professor Adamson, however, has also raised some objections to the formula, it seems desirable to explain its meaning and mode of derivation more fully than was done in the first edition. In the first place, as regards the theory of dimensions, the formula is clearly correct. The rate of interest expresses the ratio which the sum paid per annum for the loan of capital bears to the capital. The interest and the capital are quantities of the same nature, the ratio being an abstract number. Divided by length of time rate of interest will have the dimension t to the power of negative 1. Or we may put it in this way: interest is paid per annum, or per month, or per unit of time, and the less of the magnitude of this unit, the less must be the numerical expression of the rate of interest. Simple interest at 5% per annum is 0.416% per month, and so on. Hence time enters negatively, and the dimensions of the rate of interest will be t to the power of negative 1. Or again we may state thus symbolically: the capital advanced may be taken as having the dimension m, the annual return has the dimension mt. Dividing the former by the latter we obtain m over mt equals t to the power of negative 1. Now the formula f prime t over ft clearly agrees with this result. For the denominator is a certain unknown function of the time of advance of the capital T. We may assume that it can be expressed in a finite series of the powers of t, and the numerator, being the differential coefficient of the same function, will be 1 degree of power less than ft. Hence the dimensions of the formula will be tn to the power of negative 1 over tn, or 1 over t, or t to the power of negative 1. It must be carefully remembered that it is the rate of interest which has the dimension t to the power of negative 1, not interest itself, which, being simply commodity of some kind, has the dimension of commodity, namely m, of the same nature, and having the same dimensions. The function of capital is simply this, that labor which would produce certain commodity m1, if that commodity were needed immediately for the satisfaction of wants, is applied so as to produce m2 after the lapse of time t. The reason for this deferment is that m2 usually exceeds m1, and the difference or interest m2 minus m1 is commodity having the same dimensions as m1. Hence the rate of interest apart from the question of time would be m2 minus m1 divided by m1, and the quantities being of the same nature, the ratio will be an abstract number devoid of dimensions. But the time for which the result of labor are foregone is as important a matter as the quantity of commodity. The amount of deferment is m1t, so that the rate of interest is m2 minus m1 divided by m1t, which will have the dimensions of t to the power of negative 1. Exactly the same result would be obtained, however, if we regarded the use of capital from a different point of view. Capital and deferment of consumption are not needed only in order to increase production, that is to say, the manufacture of goods. They are also needed to equalize consumption, and to allow commodity to be consumed when its utility is at the highest point. Now, when certain commodity is consumed within an interval of time, the utility produced will, as we have seen, possess the dimensions mut to the power of negative 1 t, or mu. Suppose that instead of being consumed within that interval, the commodity is held in hand for a time before being consumed at all. Then the amount of deferment of utility will be proportional both to the interval of time over which it is deferred and to the utility which is deferred. Thus the amount of deferment will have the dimensions mut. The increase of utility due to deferment will clearly have the same dimensions as were previously determined, namely mu. Hence the ratio of this increase to the amount of deferment will have the dimensions mu over mut, or t to the power of negative 1. and this result corresponds with the dimension of the rate of interest as otherwise reached.